All right, pentagon VWXYZ is shown on the coordinate grid. A student reflected pentagon VWXYZ across the x-axis to create pentagon VWXYZ prime. Okay, so remember when we do a reflection, we want to highlight the axis that we are reflecting over. So we're reflecting over the x-axis, so we want to highlight that. All right, so which rule describes the transformation? We always start off with our normal xy, and we're going to be reflecting, so we're just going to be changing one of the signs to the opposite. Okay, so we're not going to be adding because we're doing a reflection, and most of you that got this wrong picked this answer, which I don't really understand why you picked that answer, but we're not going to be adding. It's not going to be B. So we have our xy, and either our y turns negative or opposite, or our x turns opposite. Okay, this one here is going to be if it was a rotation. So our x and y are not going to be changing places. So it's not going to be C. So what you would do is each point you're going to just reflect it over the x-axis. So V right here is 1 unit away, so it'd be 1 unit up. So what you can do to help yourself is for V, it was at 4, -1, and V prime, when we reflect it, it's at 4, +1 now. Okay, so we can see that our x's stayed the same, but our y's turned opposite. All right, and it can be a little bit confusing because it was negative and now it's positive. And you like to think of this as being a negative y, but this is really turning it opposite. So that's going to make it answer choice A. If you want to reflect the whole thing, you can. Or you can just remember when we're reflecting across the x-axis, the x's stay the same. So either way is fine.